Hi everyone, today we are going to talk about different kinds of mixtures. Alright, so in the warm-up we reviewed the two main kinds of mixtures, homogeneous, made of the same things, and heterogeneous, made of different things. Remember that mixtures are physically combined, okay? They're not chemically combined. Okay, we'll start with this macaroni salad video, which will give us a broad overview of the three kinds of mixtures that we want to talk about today.
The world we live in is made of things. Billions and billions of different things, like pickles and pianos and dump trucks and octopi. And even though these things seem totally different, they're all made of the same stuff, just combined in different ways. To give you an idea of how this combining works, let's take something apart. Let's start with this bowl of macaroni salad. If you were to reverse a recipe for macaroni salad, you'll see it's made by mixing together a bunch of ingredients, like macaroni, mayo, vinegar, vegetables, and mustard. This type of combining is called a mixture. When you make a mixture, you're combining two or more things together without actually changing the chemical identity of those things. Like mud, for example. The soil and water in mud haven't actually changed. They're still soil and water. You've just created a mixture of soil and water. Mud. It turns out that macaroni salad is actually a mixture of mixtures, because many of the ingredients, like mayo and mustard, are already mixtures themselves, which is nice for us because if we look closely, we'll see the three main types of mixtures that exist. The size of the particles in a mixture determines the type of mixture. On one end of the scale is a suspension, like our muddy water example. You get this if you take big chunks of something and mix it with something else, so those chunks are just floating around. Take runny mustard, for example. You'll see a bunch of little particles like mustard seeds, pepper, allspice, and minced shallots all floating around in a liquid, in this case, vinegar and water. This is called a suspension because you've got particles of one thing suspended in another. Now, on the other end of the spectrum is a solution. The particles in this mixture are so small, they are the actual molecules. A solution is sort of like a suspension of molecules, where one type of molecule is blended or dissolved with another. Vinegar is an example of a solution where the molecules of acetic acid are blended with molecules of water. The chemical properties of the molecules haven't changed, they're just evenly mixed together now. Salt water and carbonated soda are both examples of solutions where other molecules are dissolved in water. The last type of mixture is called a colloid, which is somewhere between a suspension and a solution. It's when you take two materials that don't dissolve and you make the particles so small that they can't separate. Mayo is what happens when you take oil and water, which don't mix, and you bind them together, usually with the help of another substance called an emulsifier. In the case of mayo, it's lecithin found in eggs. And now you're left with really small globs of oil hanging out with really small droplets of water. Whipped cream, hairspray, styrofoam, and jello are all other examples of colloids. So, let's get back to macaroni salad. You've got colloids like mayo, suspensions like mustard, and solutions like vinegar. But you've also got celery, shallots, and all other vegetable chunks that are also part of the salad. These aren't mixtures really, but we can break them up. Just like a TV can be broken up into smaller and smaller complex component parts. In the case of vegetables, if you keep breaking things up, you'll eventually end with thousands of complex organic molecules, things like ATP synthase, and RNA transcriptase, and water. So now, once we've unblended all the solutions, unmixed all the colloids, separated all the suspensions, and taken apart all of our vegetables, we've reached the end of what we can unmix physically. What we're left with is a whole bunch of molecules, and these molecules remain chemically the same, whether they are by themselves or thrown together in a salad. If you want to separate these guys even further, we need to unmix things chemically, which means we need to start breaking some bonds.
Alright, so first we'll talk about suspensions. So these appear to be well mixed, but over time they separate. And so this is a heterogeneous mixture because we can see different parts, right? So in salad dressing, the oil is on top, and then you have your acid, water, and other things on the bottom. So a suspension, again, separates over time. Other examples of suspensions, horchata, one of my favorite drinks. The cinnamon sinks to the bottom. Sand and water is also another good example of a suspension. Eventually the sand sinks to the bottom. Okay, try to come up with some of your own examples of suspensions. And then we have solutions. So solutions are homogeneous mixtures. Another name for solutions is homogeneous mixture. And so these are the same or uniform throughout. So most juices, lemonade, apple juice, carrot juice, most juices are homogeneous mixtures or solutions. And so there are two parts to a solution. You've got your solvent, which is the main ingredient, and this is usually going to be water. Okay, so water is the most common solvent. It's often referred to as the universal solvent. It dissolves other things. And then you have your solute. Your solute is everything else. So whatever is getting dissolved, so it could be your salt, your sugar, if you're making lemonade, maybe lemon juice, right? It's whatever you have less of, okay? Make sure you know the difference between these two words, solvent and solute. Okay, and lastly, we're going to talk about colloids. So colloids are kind of in between these two things. As you can see here, colloids are made of particles larger than solutions, but smaller than suspensions. It's actually heterogeneous. So even though they might look the same throughout, if we looked under like a microscope, we would see different parts. And so if we can see different parts, if we know there are different parts, then it must be heterogeneous. Some examples of colloids, the video mentioned mayo, but milk is a common example of colloids. It's made of fats and proteins and whey, and whipped cream is another example of a colloid. There are 4 ways of separating mixtures. Decanting is basically pouring off liquid to leave the solids. So if you had sand and water, decanting is a good option. A centrifuge is a device that separates substances based off different densities. So this little machine here, it'll spin a lot. You might have seen this in a sci-fi movie. And basically it'll separate your substances. The more dense objects collect at the bottom. And more commonly, you may use a filter to separate mixtures. You know, if I'm making pasta, I might use a filter to separate the pasta from the water, or to make coffee, you might use a filter. And then evaporation. If you've ever been to some tide pools, you'd see little salt crystals on the rocks, and that's because of evaporation has separated the water from the salt. Okay? Make sure you know the different ways to separate mixtures.